Hi everyone, welcome back to the channel. My name is Ernie. This video is a continuation of our previous video where we analyze how many buildings were affected by flooding using GHSL data, which has a spatial resolution of 100 meters. In today's video, we are going to do something similar, but this time we are using a more detailed data sets. The ESA WorldCover 2020 product, which provide land cover classification at much higher spatial resolutions of 10 meters. This will help us get a more accurate estimations how much built area was impacted by flooding than the data using the GHSL. But if you want to know detail about uh, this video, you can find in my YouTube channel and try to learn about the code. Okay, let's jump to the Google Earth Engine's platform. First, you should sign in, and after you sign in, you can go to the code editor. In code editor, you can write your code there. For the first step, you should define your ROI. Today, I will use ROI from my country, Indonesia, the Mark Regency as my ROI, and then just add your ROI to the layer and make it a center object and run it. And after a few moments, your ROI will be showing in your on your window like this. And after that, as I mentioned before, we will use data from ESA land cover. Sorry, land cover. So we will use this data set. This data set is a land cover that already mapped by ESA in 2020. So we will compare with our result before. So this product is the resolution is 10 meters. So you can imagine there is very high resolutions if you compare with the data set from GHSL because the GHSL provide us a 100 meters and the result it will be different because of these resolutions. So as you can see that the build-up area is the value is 50. So in our code, we will filter with this value. So just import it to our code. I will copy the snippet. And here you can write the code is for example for data sets and get the first image. And after that, for urban or build-up area, you can write data set dot filter equal with 50. So we already filter out only those pixels only for 50 or build-up area. And here for the visualizations, the palette is gray for non-urban and white is for urbans. And this for I add to the window and just run it And after a few moments, you will find this area that white color is indicate the build-up area. If you want to compare with the satellite data, you just make it the transpirations less so you can compare it. So here, because the spatial resolution is 10 meters, very high spatial resolution, so you can find its very details if you compare with data from GHSL. But the data GHSL is provide for us data for urban area, especially from 1975 until the projection in 2030. So so based on which one you need, but if you need high resolution, this one is maybe you can choose. But if you need maybe for monitoring for a long times period, you can use the GHSL data. Okay, the next step is we calculate the total area of these build-up regions using the pixel area comparison. So this one is the code that we take this urban area and use this reducer. We use the sum, and for the geometry is with the ROI bounds here and the scale, because if, as I shown you before that the scale is 10 meters and get the value is 0. So and this one is for print our build-up area in hectare, because here I divide with the 10 to the power of 4. So the result it will be in hectare, and just run it. And after a few moments in the console, you will find that build-up area in hectare is 89.03 hectares. Now let's look at flooding. For the details, how step by step you can find in the previous video that I have already explained in that video, how to get the flood extent or flood inundation in your ROI, and you can learn from that video. And after apply these all steps, the filtering, the what is and use the threshold. For example, here's do the speckle filtering and get the threshold for the flood area, and after that you will get the map. And for this map is the flood area, it will be showing in blue colors, and just run it. And here is I have already calculate this code is for calculate for the flood area in hectare. You can see here that the reducer I use the sums, but before that I have already multiplied with 10 the power of minus 4. So the flood area it will be in hectare. So if you see here, the flood area is approximately is 16,018 hectares. So you can imagine it's very and the build-up area only 86.03 hectares. Now, for the most important parts, which of these build-up areas were actually affected by flood. So here we will combine or overlay build-up area and flood area, and to isolate those urban pixels that intersect with the flooded zone. So we will overlay it, get the intersect, and this intersect is it will be is indicate that build up area that's in fact or affected by flood. And this code is for calculation the build up area that flooded, and similar with the formula before, we will use reducer is sum, and this one is already we multiply with the 10 the power of minus 4, and the scale is 10 meters. And here is for get the what is build up area affected by flood in hectare, and just run it. And after a few moments you will get this whole area. So build up area 80 hectares, and this is the total of the flood area. And this one is for build up area affected by flood in December 2020 is around or is approximately 19.6 hectares. And if you want to see, this is for the flood area that already I mentioned is 16,000 hectares. And this is the flood. Oh, yes, you see it's very small, it's tiny. The bill of area that's affected by flood, it's very tiny. So you can see here, very small, but the totals of the build-up area affected by flood is approximately 19.6 hectares. And in the tags menu, you will get the urbans, but if you want to get these all layers, you can just export it to your G drive or other file. Okay, that's all from my side. And if you found this video helpful, don't forget to give a thumbs up, leave your question in the comment, and subscribe for more videos on satellite data analysis and geospatial insight. And thanks for watching, and see you in the next one.